Hello, this is Team 8's final presentation. We are Grand Engineering. There's myself, Katie, with Due Diligence, Andy with Traffic, Amiali with Water, Billiam with Structures Pedestrian Bridge, and Joaquin with Geotech. This is Katie Sinclair. I'll be starting off the presentation with Due Diligence. Quick overview of this presentation. I'll begin by talking about the project location and current description of the land, then go into detail with the land use plan and emergency services on the site, including the Rise and Shine Stadium. I'll then talk about the cost for the due diligence portion of this presentation and the sustainability and value added to the community. To begin, this project is located at the southwest corner of the Loop 202 in the city of Phoenix, and it is 571 acres. These 571 acres are bound by West Ray Road to the north, South 35th Avenue to the east, West Chandler Boulevard to the south, and South 43rd Avenue to the west. This site has a current zoning of RE35, which is single-family residential, is part of the South Mountain Preserve, and has a natural drainage from the northeast to the southwest. The land use plan is shown on the right, with residential to the north, offices and commercial to the northwest, and parks and open space to the northeast. Rise and Shine is proposing to include a police station on site, as the current one is 11 miles away. Additionally, the current fire station is 4.3 miles away. Additionally, the nearest hospital is 4.5 miles away, the nearest elementary school is 4.3 miles away, and the nearest middle school is 8.8 miles away. There are no high schools in the area, which is why Rise and Shine is proposing to include a high school in Parcel 1. The key feature for our site is the Rise and Shine Stadium that will seat 40,000 people and is located near the freeway for easy access. This site will cost $10 million to purchase. It'll have conceptual review service fees of $2,700 and base review service fees of $405,000. The total due diligence cost will be almost $11 million. We as Grand Engineering are recommending the use of solar panels, green waste, and recycling throughout the site wherever possible, and especially in the Rise and Shine Stadium. Rise and Shine will provide job opportunities, offer entertainment and shopping experiences, and be a place for residents to call home. It'll benefit communities through youth programs, community centers, community events, and funding of schools and emergency services. To summarize the due diligence portion of the Rise and Shine community, it consists of 571 acres in the city of Phoenix, is surrounded by the South Mountain Preserve, has 9 different land uses with the Rise and Shine Stadium being the key feature, has a total cost of roughly $11 million, and will guarantee to offer a home, develop the economy, and maintain a safe community.
Hello everyone, my name is Andy Atondo and I will be presenting the traffic analysis done on the Rise and Shine site. The Rise and Shine site is 571 acres located off the South Mountain Freeway. There are 16 parcels with 9 different land uses. Currently, there is one exit that promotes access to the site. It is called the Cuivre Way. The land contains a road called San Juan Road and it does not have any classifications yet. The only traffic volumes available are the proposed volumes on the freeway for the year 2035. Here we have the proposed land use plan. On event days, the southwest corner will be highly congested due to the visitors of the Rise and Shine Stadium. These are the roadways that will travel through the site. All the names come from existing roads that align elsewhere. The freeway is clearly shown and the boundaries are marked as dotted lines. The trip generation calculations were completed first. The rates came from the trip generation manual. The total amount of weekday trips generated were used for the next computations. The most trips generated came from parcels 9 and 12. The directions of approach diagram displays percentages of where vehicles will enter and exit the site. As you can see, that most vehicles will enter and exit through the southwest corner near the freeway. Before starting the trip distribution and assignment calculations, the roads needed to be broken up into segments. A segment is a portion of a road. The names and colors to these segments match those that will be seen in the upcoming slide. After the segments were assigned, we began the trip distribution calculations. There was a percentage allocated to each segment that described how vehicles were predicted to travel through the parcels. Every total at the end of the road was equal to 100%. To get the correct number of trips assigned to each segment, we used the total trips generated and the percentages of the distribution. The total trips on one road was the annual daily traffic used for that road. Using the annual daily traffic numbers and the roadway classification criteria from the City of Phoenix, we were able to classify the roads as either local, collector, or arterial roads. Here is a diagram that illustrates the table shown in the previous slide. Most of the roadways in the Rise and Shine site are classified as collector roads. There are a total of 53 intersections in the site. For each intersection, we needed to determine if a traffic signal was needed there. To do that, we used the signal needs criteria table that is presented here. Here's an image that shows all the traffic signals needed for our intersections. Every intersection that did not need a traffic signal was issued a stop sign. The cost section for the traffic analysis included traffic signals, red light cameras, and stop signs. The total cost was $11,697,260. This cost included the initial implementation and annual maintenance of each system. Enforcement of carpooling and ride-sharing will create a sustainable environment. The range of areas to relax and hang out will draw visitors to the site. Being the home of the Phoenix Rising Football Club will be the most desirable feature.
Hi, my name is Amiali Santibáñez, and I will be presenting the water resources discipline. A quick overview of what I am going to be presenting is the existing water infrastructure, the anticipated water demands, the water system layout, and the sustainability approach. The Rise and Shine development is located in an area where it is not accessible to existing water infrastructure. The closest existing water infrastructure is in the Foothills Reserve residential community, which is located southeast of the Rise and Shine development. There are 12-inch water mains along West Shaughnessy Road. To connect to existing water infrastructure, 12-inch water mains near West Erie Street would be extended. Due to the site location and expenses, a self-sustaining water system was determined to be the most efficient method. The anticipated water demands were calculated based off of the City of Phoenix design standards. The demand factors that were utilized are displayed in the table. The 16 parcels generated an average day demand of 1,540 gallons per minute, a peak hour demand of 2,620 gallons per minute, and 5,620 for the peak hour plus fire flow scenario. Parcel 16 was determined to have the highest fire flow factor of 3,000 gallons per minute for 2 hours. The overall self-sustaining water system consisted of 3 wells, 1 tank, 40 8-inch water mains, and 31 12-inch water mains. For modeling purposes, the tank and elevations were not included. 12-inch water mains are located near grid arterials, and 8-inch water mains are located near mid-section line streets. The water system layout totaled to $5.2 million. Analyzing the average day demand, the peak day demand, and the fire flow scenarios, the hydraulic model shows that the Rise and Shine development can be adequately served by the proposed system of 8-inch and 12-inch ductile iron pipe water mains. For the sustainability approach, the water discipline wanted to include the community. The residential units will be required to meet the LEED V4.1, which are requirements set by the U.S. Green Building Council. An example of the LEED V4.1 requirements is the homes will be water sense labeled. This will be done during the design and installment process. By implementing the design factors, this will help reduce the amount of water that will be used. To keep the community informed, summary reports will be generated. The reports will update the community about their water usages. The summaries will include groundwater level reports and different tips on how water usage can be minimized throughout the community.
Hello everyone, my name is William Ko. Today I'm going to share about the project that I did for my senior science class. For this project, I'm a part of grant engineering team and I'm responsible to design a new pedestrian bridge that crosses over the wash. In order to calculate the required dimension of the bridge components, the following design code were used as shown on screen here. On this slide, the left figure shows the location of the bridge and is located over the wash between parcel 8 and 11 of the property. On the right figures, it shows the length of the wash that measured on the Google map and it is 36 feet. This is the first alternative design of the project and is used 3 components of W27 by 84 steel girder And as you can see on the slide, the cross-section view, dimension, and property information can be found here. The second and last alternative design of this project is using three components of type 1 H2 iron concrete girder and cross-section view, the profile view, and then the plan view of the roadway is shown here. For the design loads, the loads, live loads, and wind loads of the bridge component value were given in LRFT H2 bridge design book, and the only subway of the deck was needed to calculate as shown in the table on the left. And then we can get the shear and moment diagram according to the loads information, and the maximum moments were found as 785 cubic feet. I used the AutoCAD software to design this bridge, and the dimensions can be found on the screen here. This slide represents the total cost for both alternatives, and the first alternative of steel girder bridge costs $161,594, and the second alternative of concrete girder bridge costs $160,840. After analyzing both the design, it found to be steel girder bridge is the best choice for the clients than concrete girder bridge, because steel is the most environmentally friendly materials than concrete girder bridge. I believe this pedestrian bridge project will add value to the property because it will bring safer, easier, and reduced traveling time experience to the client. For sustainability purpose, we will use solar power panel for the lighting on the bridge and steel material than concrete. Thanks for watching my presentation. Have a nice day.
Hi, I'm Joaquin. I'm Team 8, and I will be discussing the geotechnical report. To summarize, I'm going to discuss the proposed development, the geological explorations, laboratory results, foundation recommendations, sustainability, and cost estimation. During field explorations, there were no existing structures on development, meaning that there will not be an opportunity to retrofit existing foundations. The site is mostly composed of a gravelly surface and a clayey, sandy subsurface. Areas of subsidence are shaded in yellow. The highest recording is 0.4 inches. The map indicates no subsidence on the development. According to the U.S. Geological Survey, Phoenix is not in an earthquake hazardous area. Using the data retrieved from the Arizona Department of Water Resources, the water table is at a depth of 965 to 1,015 feet, indicating that it does not need to be considered in design calculations. The location of each boring is shown on the map. Soils were obtained using a CME 75 drill rig with a hollow stem auger. Using SBT method, the average blow count end value is 27, and adjusted blow count with 60% hammer efficiency is 40 at a depth of 3 feet. The table shows the laboratory results obtained, and the averages are highlighted in red at the bottom. Using Terzaghi method to calculate bearing capacity, the average ultimate bearing capacity is 30 kips per square feet. Using a factor of safety of 1.5, the allowable bearing capacity on soil is 20 kips per square feet. Using previous data, it is recommended that lightly loaded structures like residential homes use slab on grade, multifamily, and commercial buildings shall use a spread footing. Heavy structures like stadium or school shall use a pile foundations. The recommended foundations for each land use is listed in the table. The proposed Phoenix Rising Stadium on Parcel 8 will use a pile foundation due to its massive loading. Using Norland's general equation for ultimate pile capacity, the value comes out to 463.8 tons, shown in the bottom in red. The design area is 1 square foot. It's just over a foot in diameter with a length of 40 feet. The retaining wall placed on Parcel 14, shown on the map below, has been evaluated for 4 modes of stability by checking the factor of safety with respect to the overturning moment, sliding bearing capacity, and eccentricity, and meet all requirements. To promote sustainability, piezoelectric devices can be placed under roads, preferably asphalt pavements, to capture mostly kinetic energy from vehicles and thermal energy and convert it to electrical energy. It can be a direct source of power for city infrastructure, reducing the use of external power sources. The savings will reflect on monthly maintenance costs. Finding the volume and quantity of each foundation using a unit price of concrete of $90 per cubic yard, the estimated cost comes close to $2 million. To summarize, I discussed that there is no existing structures, the site is mostly a gravelly surface and a clayey, sandy subsurface. There's a deep water table, no subsidence or seismic activity. Recommended foundations and retaining wall were discussed, and the estimated cost is $2 million for the Rise and Shine proposed development. This concludes Teammates' presentation. Thank you for watching.